I have no doubt that you can do it. Absolutely none. I know you can, in fact. All right. So, what do you guys think?
87.
I hear 86. I hear 87s. Why? How? What you got?
Because if you take 1, multiply it by 2, and add 1,
Mm-hmm.
you get that, and it keeps happening. And then so 2 multiplied by
Mhm.
43 plus 1 is 87.
Yep, totally fine. I see you've got a set of 2 here. I've got 2 sets of 2. I've got 3 sets of 2. So we could write this as 1 times 2 plus 1, 2 times 2 plus 1, 3 times 2 plus 1. So when we're looking for pattern number 43, we could write that as 43 times 2 plus 1. And we get 87. Okay, there's many different ways to see it or to notice the pattern. Yes, dear. Absolutely valid. That's another way to do that. And that's one of these things. There's lots of different ways to do this, is to notice that this is 1 plus 2. This is 2 plus 3. This is 3 plus 4. So you could do 43 plus 44. 100% another valid way of doing that. There's not one right way through. There's so many different ways we can go through it. Okay? So when we're looking at these patterns, it's not about finding the way I went through it. It's finding a way through it that gets you to the same answer. Okay? So we'll see these patterns pop up every now and then, just kind of working through things, practicing our pattern recognition, noticing equations, being more comfortable with that manipulation, and trying to spot stuff. Okay? We are going to be in your workbooks today. We're going to be on page 5. Which I also noticed we have page numbers in very strange places. We have a couple of versions. For the whole year, we need to make sure we're paying attention to the big numbers. Because once we get past this first section, those little ones become very chaotic. And they no longer match with the big ones. We're going to look at the big numbers. So if you flip halfway through the book, we wind up with, page 47 is also called page 20. So, chaotic page numbers are fun. But we already had a burn it, so now we're doing it. So we're going to look at pages 5 and 6 today. So I got bunches. So we're going to look at this picture. We're going to kind of doing some analyzing. We're thinking about rates of change. We talked about those yesterday a bit. What's up?
Close my phone up. Oh, you got a charger?
It's like, honestly, it is, I think, the slowest charger in this building, but you can't, there's also a plug right here you could plug in. But honestly, I try not to touch y'all's phones because I really don't want to be responsible if, I'm like, my screen wasn't cracked before you charged it.
I never dropped my phone.
Oh, I am a big investor in things like the Gorilla Glass screen protectors and all of those because I am not particularly good at holding on to things.
You say that,
Oh my gosh. I will buy any case that has like a drop protection, then I get my little my gripper. I still will drop this thing. So
drop things like that.
I drop everything. Like everything.
I drop everything but my phone.
No, I drop everything.
I drop everything but my phone.
I am 100% clumsy. Which is, I think,
my glasses, but I've never dropped my phone.
I can't think of a single thing I've never dropped. Including my children, but usually I fall with them. Fell with one of them down a set of stairs. That was fun.
That was falling, not dropping.
Pretty much the same thing, especially when you're talking to a human. So, yeah, no, that would be why I have like a plate in here. That would hoverboards in your 30s. Wear wrist guards when you use a hoverboard.
So you have practice as a UPS delivery.
What's up?
You practice as a UPS delivery.
I am not delivering for UPS. I was chasing my children on the hoverboard, showing them how fun it would be as they stood there with their helmets and wrist guards upon. And then I was down, and then I rode in the ambulance.
I'm saying because they always drop everything. Like they just drop your package for a second, and it usually ends up there.
You're lucky if they don't throw it. That's okay though. All right. So we're looking at page 5. We're looking at this little graph right here. There's not a whole lot of information on it. We've got absolutely no numbers on here. Not a one. So we can't like calculate specific values. We're just looking at the comparison. Which costs more per pound, peaches or plums?
Peaches.
Why?
Because it has a steeper slope.
It has a steeper slope. So the cost goes up faster for peaches than it does for plums. So if we're looking at the same number of like pounds, peaches costs more than plums. So peaches cost more per pound. The rate of change, oops, sorry, that probably was, yeah. They cost more per pound. Because the line is steeper. You can put whatever words you want. Y'all have lines to actually write this. I just have a tendency to make my pictures as big as possible, so I just kind of write all over the place. So that's question number 1, just below the picture, if you want to write on it. I just have a tendency to write chaotically everywhere. On brand. It's a steeper line. The rate of change is higher. If we're comparing here, rise versus rise and run, they're going a lot different routes. Peaches are more expensive. It is a higher slope. It is a steeper slope. It's increasing more quickly. Many, many different ways to word it. So when I change to the next question, it's going to take all the marks off. Boop. So if bananas cost less per pound than peaches or plums, draw a line on the graph that might represent bananas. So I want you to draw on it. Where would you put the bananas?
Below plums.
I was going to say, I'm going to give us a couple of colors. So in the purple section, in the green section, or in the blue section? Blue. Yeah. It's less than peaches and less than plums. So if we had, ooh, I'm so good at drawing straight lines. Beautiful. So this would be bananas. Banana. So bananas would be less than peaches or plums. It has an even shallower slope. It is even less than peaches and plums. So we're just like trying to compare the two together, looking at that relationship. Even with no numbers, we found out a whole lot about their slopes, what they mean, what that's telling us, and all that kind of jazz. We don't even have to have numbers to be able to do these analyses. One more question on this part, and it's not actually even written on your page. I'm just using that kind of blank space down below. What is our independent variable and what is our dependent variable? Pulling out some Algebra 1 vocab. So what is the thing that causes change? And what is the thing that gets changed because we've changed something else?
Number of pounds is independent?
Yeah, number of pounds is independent. The way we can tell for something to be independent, it's what we get to control. I get to choose how many pounds of peaches, plums, bananas I want to buy. That is our independent variable. We control it, or whoever is imaginary controls it. It is also almost always, should always be your x. If you have an independent variable, it should be your x-axis if we're graphing. So that means our dependent variable is going to be what? Money, 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 money. It's our dependent variable. That changes based on what we have made a choice in the other thing we can control. So dependent variables are y. Independent variables cause the change and dependent variables are being changed. If one of our variables is a unit of time, Do we control time? So do I get to choose to go back in time or forward in time? No. So if I am trying to decide which variable time would be, would that be something that causes change in other things, or is that something that we get to change? It causes change. Time will, I'm going to go with 99.9% of the time. I never give 100% because there's always something that throws me off and that makes me rude. Be an X variable. Time is going to be an independent variable. I can't think of a time when time is not your independent variable, but
What if like we're choosing a set amount of minutes to spend on something?
then you are still choosing the minutes.
But wouldn't it be deeper?
It would, so we're going to look at a few examples with independent and dependent stuff, but for the most part, times are going to be independent. Because I can choose if I'm at work for 6 hours or 7 hours or 8 hours, that's going to change what my pay rate is. If I change the amount on my paycheck, like I spend $100, that doesn't magically make me work an hour less. We're going to have a bunch of examples with this. So just, we're going to be careful with that. But time is almost always, and I would go with almost always, be an independent variable. Okay, so we're going to practice identifying independent and dependent variables. That's pretty much what we're going to do for the rest of this time. So on the next page, if you flip over, page 6, we got a whole bunch of examples. And we're going to talk through several of them. I'm going to actually start with number 2, and then we're going to look at number 1. And I don't know if I have this as a talk and pair, sure. So talk with your neighbor on these two and see what you guys think. Which one is independent and which one is dependent. And I'm just going to tell my friends in the back that I heard a conversation earlier. Let's not check with ChatGPT. I said, let's not check with ChatGPT, as was referenced in the earlier patterns problem by some of my friends in here. What do you mean she heard that? That's crazy. Y'all were loud about it. Y'all were like super not sneaky. Okay, it doesn't technically have to be a friend. It can't be an enemy if you're feeling that froggy.
I didn't say that either.
Friends, enemies, acquaintances, random strangers.
Because how many
It changes because of how many.
like you're really large.
Look at these two and see what we can think. We're going to talk them through here in just a second.
Oh my gosh.
The independent is where it goes, like, we change.
The rate of your dog is reading on a scale. So I think the independent is the rate of the dog.
You got number
The
one.
numbers are changing.
I know it's Josh's, but I know you want them.
Independent.
Actually trying to fix this.
No, you have to do that. No, I'm saying the deepest. Yeah, because it's not changing. I'm not helping no more. Sorry, I have a bubble. This is all right, Sydney. I'm not doing it. When you do number one,
Those are kind of the same things.
the height of the grass in the yard.
Height of our grass. What is changing?
So later in
So, 1 month in summer, my grass will be short, and then 2 months.
So summer would be
3 months.
increasing.
If I mow my grass, if I have it after summer, 3 weeks.
I'm just putting.
So if your grass cannot change the time can change the grass.
So independent is changing.
Yes, sir. To be fair, no one didn't say you had to do it by yourself. Then talk
amount of time you spend in an airplane in addition to the parts of the
All right. What do we think? What's up? Yeah, one is, I think one is probably one of the hardest ones. Okay.
I said the distance traveled makes the time change.
Okay, so let's look at these. Let's look at number 2. Just because honestly, I think number 2 is easier than number 1. If you try and start with number 1, it is a little extra hard. What's up, Walter? Okay, what you got? The number of students is independent, and the dependent is the number of buses. Because I can put out the sign-up sheet and see who wants to come on this field trip. The number of students is going to be our independent because I'm signing 10 people up for the field trip. I'm signing 100 people up for the field trip. I could sign 3,000 people up if I'm taking everybody in the school. That is going to drastically change the number of buses I need. There are ways that you can kind of argue this, like if you say we don't have enough buses to do it, I can see an argument for it to be switched, and that's one of these things that is debatable. But for the most part, it's going to be that, well, I only have 10 people going on this field trip, I don't need 10 buses. That would be silly to have 10 buses for 10 people. Solo party bus. So the number of students is going to change the number of buses we need. There's an argument to be made that the number of buses can affect the number of students because if we don't have enough, I can see the argument for it, but for the most part, it's the number of students who determine the number of buses. So then let's look at number 1. I feel like that one's kind of a tricksy one. What are the things that are changing? The height of the grass, that's going to be one of our variables. What is the other variable in here? Time. The time over the summer. So which of those things is in control? Time. Time is in control. So what changes because of the time? The height of the grass. So this is one that makes that time conversation a little bit clearer because I could say a month into summer my grass is this high. 2 months into summer my grass is this high. If I cut my grass back down to this high, do I get to go back in time and have another extra month of summer? I would be mowing that grass every dang day if it would send me back in time. So what we do cannot change time, but time can change things. Which is, I believe, a song from the 80s.
So what do you think the time?
Just time.
I feel like it could go both ways.
We'll look at number 4. Let's look at number 4. Let's look at number 4. All right, so let's look at 3 and 4. And then I think the rest of them will have you guys work on your own, and I'll come around and we'll talk through stuff. And we'll talk through the end. So let's look at 3 and 4. The weight of your dog and the number that's on the scale. What's up, Walter? The dog's independent. The weight of my dog is independent. Because if I put extra food out for my dog and my dog gets a little heavier, that's going to change the number on the scale. If I put my dog on a diet and he gets a little skinnier, that's going to change the number on the scale. If I find that little magic dial on the bottom of the scale and manually turn the numbers, does it make my dog lose weight?
No.
I've changed the number on the scale, but that doesn't make my dog lose weight. Otherwise, we would all be turning that dial in the scale for any number of things. Wrestlers would turn it up a little, some of us would turn it down a little. Lots of people would do that for many number of reasons. So the number on the scale is dependent on the weight. It does not control. There we go. When I try and talk and write at the same time, different things. It does not work well. The number on the scale does not control your weight. Your weight controls the number on the scale. And there is nothing wrong with any single number on any scale. Just saying. All right, number 4 is another one that's a little bit weird. So it's the amount of time you spend in an airplane and the distance you are from your destination. So what are the things that change? So we've got time in the airplane and we've got the distance between you and your departure. What is in charge? if I change how far I am from my landing place, so let's say I'm on a trip, that's where I want to be. If I go the wrong way, does it make me go backwards in time even though I'm farther from my destination?
Well,
I was gonna say I'm farther, I can go back, but I don't get to change my time and restart my trip, and then go a little closer, and then restart my trip, and then go a little closer, and just like eat up time that way. It is changing my distance. I can change all sorts of pieces about it, but what is more in charge? The time or the distance? What is in more control? If I go backwards, did it take me back in time so I have more time for my trip?
depends.
Walking away from a trip does not give me more time
Well,
on the
you
trip.
could also be flying from like New York to LA.
Then you're just into geography time zones and you still don't make back enough to get back from the start.
But still, you're going technically.
It is
going back
not
in
backwards in time.
time. Technically, you are.
I feel like on a plane, you can't move the world. So, like, if anything, the time could change, but not the distance.
So say stop griping. The problem is if I change my distance backwards, like if I take the round trip and go back the other direction, I'm not going back in time. I can't undo it. I can change the distance. That's totally fine. But the distance I am from a place cannot control how long, like what time it is, how much time is spent in the airplane, which is why they worded it like that. Time spent in the airplane. I'm spending an hour in the plane, 3 hours in the plane. Whether I'm flying to New York, LA, or LA, New York, I'm spending the same basic time in the plane. But it's my distance that changes. Because no matter if it is from New York to LA or LA to New York, it looks like a half-hour flight or it looks like an 8-hour flight, you're still flying for 4 hours. We're in the airplane the same amount of time. So our distance was our dependent. Because if I get farther away, I can't go back in time. Unless someone invents time travel, in which case then this whole argument goes out the window. But that's not a thing yet. Someday. I fully believe that. All right, so finish it out. There's one more on this page, and then there are 5 on the next page. And once you finish them out, that's it for the day. Like, we're gonna spend, I'd say, let's do 10 minutes on that. Finish those, that's 6 of them, gives you 10 minutes. You can work with a neighbor, friend, enemy, stranger, seat partner, table mate, I don't care what you call each other, rando person that you've never met before, I don't care. We're gonna take 10 minutes, and then we'll talk through the rest of them, and then that'll be it. Be nice. Y'all chose to sit next to each other. Be nice. Let's double check. Yes. Okay.
No, it's constant. It's actually like locked as this.
Dude, you trying to look at him.
Literally, I played about what?
Awesome. Love that. My brain's in a mood today. I don't know what's happening. So.
by yourselves. All right, period.
I don't know what I've done. I cannot do it.
I see.
I have both of them stuck on the string. I don't know how I did it. I was following the instructions too.
Number 9.
No, I was.
Doesn't mean it started in the right spot.
No, one of them wasn't. Wait, I think that's how I was trying to undo it.
Yeah.
But then I got the other one like that.
What's that?
So I don't know how I did it.
I don't either.
It's become magical and I hate it.
No, stop. No, I did.
Yes, dear. Absolutely. That's 100% the puzzle.
I got one.
Yeah, yeah, that's good.
Wait, no.
Are you seeing that bad?
Before you take these. Check it.
Oh, I already did it. It's literally so, I don't wanna do it. I'm digging it. What? No.
Alright, so our main thing is I change the weight on it. Does that change the length? Yeah, I was gonna say, changing the weight changes the length. But if I just pick this up and make my rubber band shorter, it doesn't actually change the weight of that ball. Yeah.
Oh, is that?
Yeah.
Why is everybody gambling?
No, literally, bro.
Yep.
The rest of
Yeah,
them be
that's
hard.
gorgeous.
You just rushing. These two rushing going.
Yeah, you got it, you got it.
Y'all too. You feel good.
What's your old bestie?
I can't like lift my
Oh, yeah. Yeah, yeah.
but if I play like
I say, let's do that, like, that way to go on. No worries.
Half of my family like just like picking up.
That's fine, I'm just going.
I'm just trying to.
Your band?
There you go. You leave.
Yeah.
Cancer settling.
I was gonna say, I didn't have a sense of it. Oh, sorry. We're right back into it.
Oh, okay.
Hey, they better be.
Nope, just like, I change the weight.
What is this for? Oh, this is for the playoff, right?
Does changing the weight that's attached to it change the length of the rubber band, or just the length of the rubber band change how heavy this item is? So if I pull this down further, does that make this pop on the base?
0.5, that's my pick.
So the weight changes the length attached to it.
I know some of them.
I got what's it called? Before you do that.
Now you get.
I'm not part of that.
Kurt would never put money on that for his ladder you
Right?
Oh, this one too?
It's the replacement.
There's a few more.
I just clean.
Got a couple more minutes, we got a few more minutes.
You gotta look right. He's freaking everything.
Especially if it's
Easier. Yeah, I've got a charging station back there, I have some.
What?
Here. I
You can get it on the front foot.
Okay. Yeah, I've got it. That's always, you're welcome to work it anytime.
Yeah, everybody can stop being quiet.
Of course, you don't get more than 5.
That I can't help you with.
That's how they go.
I was like, I looked at them very briefly and tried them, and it just was one of those things that, nope.
My piece, see? It's not pretty. What? Wait. The Palmer knew it, huh? Which one is the Palmer?
All right, let's take a peek at these. What did we think for number 5? It's on the previous page. Sorry, making you flip stuff.
The number of times the weight is dipped.
The number of times you dip it is independent of the diameter of the camera. The more times I dip it, the bigger the candle gets. That's how you make old school candles. You take string, dip in wax. The more times you dip it, the bigger the candle. Which is why big candles tend to cost more. How about number 6? What do we think? Which one is independent? Number 6. The number of days. The number of days changes how much we owe. It doesn't have anything about the number of books. If it had number of books and the amount we owe, I'm with you 100%. It's okay. It's okay. You got the vibe of it. You had our owed as our dependent. We're good there. Okay. Is the number of days is independent, because the more days you don't turn that book in, the more money you owe the library. And just as an FYI, they never stop adding up those totals. Definitely did not, as a early college student, want to bring several $100 to the library for overdue books. I would check out like 5 to 10 at a time and just never turn them in on time. And they eventually just sent me a letter saying, oh, by the way, you owe us like $300. I went, oh. I was giving them back, just always a week late, maybe a week late.
Might as well just buy books.
Yeah, but I was a teenager. I didn't have book buying money. All right, how about let's look at number 7, the number of missing homework assignments that you haven't turned in and you're great in math. Which one is independence? The number of assignments. How about number 8, the temperature of the carton of milk and how long it's been out of the fridge? How much time? I control when I put it on the counter. I cannot microwave the milk and say that it's been out longer. I could trick somebody with that and change the temperature that way, but it would not be real. All right. Number 9 is, I think, one of the ones that has like a weird to think about. That was the one I get the most questions about. Is the weight suspended from a rubber band and the length of the rubber band. What do we think is independent?
The weight.
I was like, I heard both there. So, visual aid. Rubber band and a weight. Shroom. Pop it. Rubber band and a weight. If I change the length of the rubber band, does that change how much this thing weighs? No. So, is the length in charge? No. Is the weight in charge? The weight is in charge. So the weight is independent of the length. The length is changed based on how the weight. I can make this thing weigh more and pull it farther. I can pull it and add more weight. But the weight is in charge. The weight gets to choose it. Most of the time, it depends on the situation. That one, because it could be like cost versus budget. Like there's all kinds of things that it could be. So let's look at 10 real quick. Diameter of a pizza and its cost. What do we think? As like the pizza, the diameter of the pizza, it's independent. And how much it costs? Dependent. The bigger the pizza I order, the more it's going to cost. Barring coupon deal sale stuff. When we're looking at these situations, we're looking at very basic situations, not getting extra with it. All right, last one. The number of cars on the freeway and the level of the exhaust fumes in the air. Number of cars is in charge of that. Barring LA weather nightmares. Okay? So that's what we're doing today. That's everything. Okay? So y'all have about 5 minutes to the end of the period. We do not have any homework yet. The first homework, I'll tell you about it tomorrow. But we'll have time in class to work on it. So if you have your computer with you, you can probably get it done in class. We'll have plenty of time. Okay? But yeah, that's kind of the vibe.